Here's a fun fact to share on your next coffee run.
Caffeine is the most widely used psychoactive drug in the world.
Now, just because it's classified as a drug, no one is saying your morning cup of joe will harm you. But researchers are interested in links between caffeine and other drugs that might. In past studies, caffeine use has been associated with illicit drug use and risky behaviors. Today, Ryan Bachtell, a neuroscience professor at the University of Colorado Boulder, talks about his latest paper in neuropsychopharmacology, which explores the relationship between adolescence, caffeine, and cocaine. As it turns out, caffeine indirectly affects the dopamine system, the exact same system triggered by cocaine.
So cocaine and methamphetamine really operate through the dopamine system, which you've probably heard is part of what people consider to be the brain's reward system. Caffeine sort of alters the dopamine system very, very indirectly, and it also enhances dopamine, but in a much more subtle way compared to cocaine and methamphetamine.
So, what did your team see in the way that the caffeine dopamine interaction overlapped with the cocaine dopamine interaction?
The animals consume caffeine for 28 straight days. This is during their adolescent period. And then there's a 7-day washout period where they don't receive any caffeine or consume any caffeine. And that's when we do our behavioral testing and we analyze the brains of these animals. We looked at the hyperactivity of the animals that had consumed caffeine, and we see that caffeine consumption during adolescence makes them more hyperactive to cocaine.
Why study adolescent populations specifically?
First and foremost, caffeine is the most widely used psychoactive drug in the world. And you're probably aware that there's a huge industry for energy drinks. These energy drinks are primarily being marketed to adolescent populations. And we've seen a tremendous, about a 400% increase in caffeine consumption over the last 30 years.
Did you say 400%?
It's astronomical how much more adolescents are consuming caffeine now compared to 30 years ago.
Did you see changes in adults?
So when we did these same studies giving caffeine to adult animals, we didn't see the same changes in the dopamine system. We didn't see the same changes in cocaine responding. So it was really this developmental specific effect that occurs during adolescence. That, I think, was the most surprising and informative part of the study.
Is there any sense of why the adolescent brain might be more vulnerable to these effects or changes as opposed to the adult brain?
The main sort of holes in the literature and the research is that we don't know exactly how caffeine affects brain development. It's a hugely understudied question. So we know that the adolescent brain is an extremely delicate state where the cortex that sort of helps to make higher order decision-making sort of processes is still really in flux during this adolescent period. And so we'd like to start exploring how that system can then guide some of the other brain systems, like the dopamine system, for example.
Was behavior the only thing your team looked at?
We also looked at the rewarding properties of cocaine. So cocaine is obviously a drug of abuse, and we know that most drugs of abuse have some sort of rewarding property to them. People find them pleasurable. So we measured that in our rats, and we found that the rats that had consumed caffeine during adolescence were more likely to find it pleasurable or rewarding in our behavioral tests.
And how do you measure pleasure?
Well, we used a procedure. It's called a conditioned place preference, where we pair an environment with cocaine, and with it comes the subjective effects of cocaine. And so then we ask the animal to choose, would you like to spend more time in that compartment? And typically they tell us that yes, they do. In other words, they develop a learned response to spend more time in the area that they got cocaine.
One would assume that if I'm no longer feeling energized by my morning cup of coffee, it's completely left my body. But it sounds like what you're saying is there are these lingering effects in my brain.
Yeah, you're exactly right. So we see these changes 7 days after caffeine consumption has stopped. And what's even more fascinating is we've actually pursued longer periods of time where they haven't received caffeine. and we still see those changes out to almost 2 months.
It's so interesting to me, though, that dopamine is sort of what caffeine has the indirect effect on, yet it's the dopamine system that's seeing the most lasting residual effects.
Yeah, and so that was actually one of our, most surprising findings, I guess. We didn't really expect to see such robust changes in the dopamine system, although we definitely think that that's sort of at the heart of the increase in cocaine sensitivity that we see.
As you think about upcoming research and filling in some of the holes in the literature, what are some avenues you want to explore alongside thinking about the development of the cortex?
The other thing that we're interested in pursuing ties into caffeine and anxiety. So we know that high doses of caffeine consumption can produce anxiety-like responses, perhaps jitteriness, etc. Anxiety is a predisposing factor to the development of drug addictions, and so we're interested in how caffeine might produce anxiety and change the functioning of our brain's anxiety systems that might lend itself to development of different substance abuses.
That was Ryan Bachtell, assistant professor in the Department of Psychology and Neuroscience at University of Colorado Boulder. The article from Dr. Bachtell and his colleagues can be found on the Neuropsychopharmacology website at www.nature.com/NPP. This is a download from Nature Publishing Group. I'm Molly Webster. Thanks for listening.